Now, Hess's law basically follows the same pattern that we're going to see in this example. In this example, it says, for the following example, calculate the unknown delta H value from the given delta H values of the other equations. Okay. Basically, what we have to realize is we need to find the delta H of this reaction here, and the way we're able to do that is by manipulating these two reactions here in order for them to come out to this equation above. By manipulating them, we'll be able to find the delta H value we're missing. Now, it seems kind of complicated, but it really is easy. All we have to do is go compound by compound and see where we find them. If things don't match up the way we see them, we have to just manipulate the equation so that they do. So let's take a look here. We're going to take a look first at sulfur solid. We look on the two bottom equations and say, where do I see sulfur solid? We're going to see sulfur solid right here and only here. Now we're going to say here it does not match what we have up here. Up here we only have 1 mole of sulfur solid. So I need to find a way of converting this also into 1 mole of sulfur solid. And the only way we can do that is by multiplying by 2. And not just the sulfur solid, but the entire equation. So when we multiply everyone by 2, all those halves become 1. So 1 mole of sulfur solid plus 1 mole of oxygen gas gives me 1 mole of SO2 gas. And here we're going to say, if we multiply the equation times 2, then we're also going to have to multiply delta H times 2. So then that becomes negative 593.6 kilojoules. And remember, how did we do that? We just multiplied it by 2. Because I manipulated that equation, it's no longer used. It's gone because it's changed into this new one. Now, I have 1 mole of sulfur solid just like I have up above. So we're good. Next, we're going to look at oxygen gas, O2. Where do I see O2? I see O2 in 2 places. I see it here in the second equation, and I see it here in my brand new first equation. When I find it in more than one place, that means I'm going to have to skip it, because it's kind of hard to gauge what we should do next. So if you find a compound in more than one place, skip it and move on to the next example. Now we have SO3 as a product, and there's only 1 mole of it. Here we have SO3 down here, but the problem, there's 2 problems with it. 1, it's a reactant, but we need it to be a product. And 2, there's 2 moles of it. So what we're going to do first is we're going to reverse the reaction so that it's also a product just like up above. So we're going to reverse the entire equation. So my reactants now become products and my products become reactants. Everything gets reversed. And just realize this, anytime I reverse a reaction, that reverses the sign for delta H. So delta H was positive, now it becomes negative. Now, we have 2SO3 as a product, but we only need 1 mole of SO3 because that's what we have up above here. We only have 1 mole of SO3. So what I need to do lastly is I'm going to divide by 2 because we need to get rid of that 2. So this becomes SO2 gas. This becomes SO2 gas plus half O2 gas gives me SO3 gas. And of course, if we divide the equation by a number, then we also have to divide delta H by that same number. So this is going to get divided by 2. So now my new delta H is negative 99.2 kilojoules. These 2 got manipulated, so they're both gone. What I'm going to do next is I'm going to get rid of what are called intermediates. Intermediates are compounds that look alike, but one is a reactant in one equation and the other one's a product in another equation. Our intermediate here is SO2. Here in this first equation, it's a product, but in the second one, it's a reactant. So because one is a reactant, one is a product, they're going to cancel each other out. So now they're totally gone. Now all we're going to do here is we're going to bring down everything that didn't get canceled out. So the sulfur solid didn't get canceled out, so it comes down. This 1 mole of O2 combines with this half O2, they're both reactants, so they don't cancel out, they add up. So 1 plus half gives me 1.5, which is the same thing as 3 over 2. And then this SO3 comes down. And if you notice, the equation we just isolated is the same equation up above. And we're going to say that to find the delta H value of this equation, which we're going to say is delta H3, all you do is you're just going to combine delta H1 plus delta H2. So just add them up. So it'll be negative. I'm going to take myself out of this image, guys, so we can see the work. So it's going to be negative 593.6 kilojoules plus negative 99.2 kilojoules. So that gives us negative 692.8 kilojoules. Now just realize, all we have to do is we have to manipulate the equations with given delta H values to find the delta H of this reaction up here. That's the approach you need to take. So go compound by compound and see where you find them. Make sure you have to manipulate them by either multiplying, dividing, or reversing. Doing one of those 3 steps will help us isolate this equation. Once we do that, just add up your delta H values together. Hess's law can be challenging, but always take that approach to help you better organize the information.